Have you ever wondered why the moon is slowly drifting away from Earth? It's a fascinating and complex phenomenon that involves the interplay of gravitational forces, tidal interactions, and the dynamics of our planet's rotation. Today, we'll dive deep into the science behind this celestial dance and explore why the moon is moving away from Earth. Welcome to our channel. In today's episode, we're going to explore one of the most intriguing aspects of our solar system, the gradual separation of the moon from the Earth. This isn't just a random occurrence. It's a process governed by the laws of physics and has significant implications for both celestial bodies. First, let's start with some basics. The moon orbits Earth at an average distance of about 384,400 kilometers, or roughly 238,855 miles. But did you know that this distance is increasing? The moon is moving away from us at a rate of about 3.8 centimeters, or 1.5 inches per year. This might not sound like much, but over millions and billions of years, it adds up to a significant change. To understand why this is happening, we need to dive into the concepts of tidal forces and angular momentum. Tidal forces are the result of the gravitational interaction between Earth and the moon. The moon's gravity exerts a pull on Earth's oceans, creating what we know as tides. These tides cause the water to bulge out both towards and away from the moon. Now, as Earth rotates, these tidal bulges try to stay aligned with the moon. However, because Earth rotates much faster than the moon orbits, the bulges are actually carried slightly ahead of the moon. This slight misalignment means that the gravitational pull from these bulges exerts a forward force on the moon, effectively giving it a small push in its orbit. This process transfers energy from Earth's rotation to the moon's orbital motion, causing the moon to slowly spiral outward. But that's not the whole story. To really grasp what's happening, we need to talk about angular momentum. Angular momentum is a measure of the amount of rotation an object has, taking into account its mass and shape. In the Earth-Moon system, angular momentum must be conserved. As the moon gains angular momentum and moves to a higher orbit, Earth must lose some of its rotational angular momentum. This causes Earth's rotation to gradually slow down. So, in a nutshell, the energy transfer from Earth's rotation to the moon's orbital motion is the key reason the moon is moving away. This process is incredibly slow, but over geological timescales, it has profound effects. Let's put this into perspective with a bit of history. About 4.5 billion years ago, shortly after the moon formed, it was much closer to Earth, possibly as close as 16,000 kilometers or 10,000 miles. The moon's influence on Earth was much stronger then, leading to massive tides and a day length of only a few hours. As the moon moved away over time, Earth's rotation slowed and the days became longer. By the time life started to flourish on our planet, the moon had moved to a safer distance, stabilizing Earth's climate and creating the conditions necessary for life as we know it. Today, we continue to measure the moon's increasing distance using precise laser ranging experiments. These measurements confirm the rate of 3.8 centimeters per year and help us understand the dynamics of our planet-moon system. But what does the future hold? In the distant future, millions of years from now, the moon will be significantly farther away and Earth's rotation will be much slower. The day length could increase to as much as 50 hours. This gradual change will continue until the moon reaches a point known as synchronous orbit, where it will take the same amount of time to orbit Earth as it takes Earth to rotate once. At this point, the moon will no longer move away, and both bodies will be tidally locked. The process we're describing is not unique to the Earth-Moon system. Similar tidal interactions occur in other planetary systems, including some of the moons of Jupiter and Saturn. Understanding these processes helps astronomers learn more about the formation and evolution of celestial bodies throughout the universe. In conclusion, the moon's gradual drift away from Earth is a result of complex gravitational interactions and the conservation of angular momentum. This process has shaped the history of our planet and will continue to influence its future. It's a testament to the dynamic and ever-changing nature of our universe. Thank you for joining us on this journey through the science of the Earth-Moon system. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating explorations of our cosmos. Until next time, keep looking up at the night sky and marvel at the wonders of our universe.